This is a presentation about oil heating and combustion chambers. The purpose of the combustion chamber is to provide a hot environment for the oil to burn. What we do is we take oil and air, we mix it together, and we know it burns best in this hot chamber. The chamber reflects the heat and provides for the containment of flame. The chamber also minimizes the amount of air required for combustion because it keeps everything in one location. If we didn't have the chamber in place, the heat would be escape, go up the flue, go into the furnace metal too fast, and we would not have enough heat or air for the combustion process. So if we take a look at this, the combustion chamber in this diagram is the area around the flame. It's inside the refractory metal and it's at the end of the air tube. The rest of the heat exchanger is around the outside. There's a gap between the combustion chamber and the heat exchanger walls. Combustion chambers can be made up of fire brick, hard brick, metal, insulating brick, ceramic, or molded material. The fire brick is basically used in large commercial industrial applications. For example, you'd see it used in a power plant or multi-story buildings. It's a much heavier than insulating brick. It takes a lot of time to heat up. The nice part about it is it does hold the heat. And large chambers are subject to shock and need to be replaced more frequently. Remember, as you heat things up and cool them down, they expand and contract. The larger the chamber, the less even this heating and cooling process is going to be. This is an example of the hard brick. And it's all held together with cement. We're going to talk about this a little bit further, but the cement that's used in the brick has to match the brick and the application, or it's going to expand and contract in a different way. Metal chambers, they're used in factory-built units. Okay, they're sensitive to improper firing rates. In other words, you can overheat them. You can heat them too fast, and if flame comes into contact with a metal chamber, a hole can be burnt right through the end of it. It's not recommended to be used with retention burners. Okay, remember, a retention burner keeps the flame very close to the end of the burner. And we replace it with precast ceramic chambers most often. Okay, this is a metal combustion chamber that has inside of it another chamber down here. Okay, insulating brick. Okay, the porosity and the lightness makes it highly resistant to penetration of heat. It glows red in about 15 seconds. Okay, and it comes in different temperature ranges. Up to 3 GPH, we use a 2000 degree fire brick. Over 25 GPH, and again, this would be like in power plants and large commercial industrial water heating environments, we might use a 3000 degree fire brick. The ranges are based on the gallons per hour. Insulating brick, again, comes down to using proper cement. Okay, we need the brick and the cement to expand and contract identically in terms of how long it takes. If, let's say, the brick expands faster than the cement, or the cement expands faster than the brick, it's going to start to crack. Okay, this is an example of insulating brick. So these would be stacked and cemented together to form the mold of the combustion chamber. Ceramic chambers are available as well. We use a special blanket that we can actually put in there to line old and cracked chambers. We need to make sure when we install an insulating blanket that we don't make it too small. The blanket can also be used as a chamber with a stainless steel binder. Okay, nothing can come into contact with this blanket after installation or it will crumble. The way the blanket is shipped to you, it comes in a plastic bag. It's moist. Okay, and it comes with a bottle of epoxy normally. What you do is you set this blanket up into shape, you put the epoxy on it, and then you fire the burner for like 10 or 15 minutes, and that will make that will harden the entire thing and make it into one solid piece. Okay, this is an example of a ceramic chamber. They're pre-molded, and you see the holes that are in here pre-drilled for the flue gases to escape. Okay, molded chambers are similar to the ceramic blanket except that no binder is needed for it to hold in shape. Replacements are shipped in the same shape they are installed in. Replacement packs usually contain a portion of insulating blankets to seal spaces and also cracks between the sections. Now, when you order a molded chamber from the parts house, it is very important that they have the exact model, a model number, and serial number of the unit you're putting it into, and if possible, make sure they have the dimensions as well, just in case they can't pull the model and serial numbers. This is an example of a molded chamber. Okay, in this case, you see they shipped a little tube of adhesive, so this would set directly into the furnace. And you've got to be very careful when you put these things in and when you carry them in the shop, in your truck, because they will break. This is an example of a kit, of a repair patch kit. Okay, you have your chamber walls, then you have the blanket, you have a little tube, you have a little bottle of silicone, and you have some usually rope or something to put around the edges. The design of the chamber is actually pretty special because it acts like a mixing bowl for the hot gas, air, and oil. Because if you think back to our combustion conversation, we have to have heat, fuel, and air for our combustion process to work. So the chamber is the mixing bowl for this whole process. The best shape for it is round or oval. We don't want to keep square corners because then we have eddy currents, and that's a pretty important term for those of you getting licensing because it does appear on state tests. But we create eddy currents which lower the flame temperature. And eddy current is when air blows out of the burner tube and hits a square corner, it creates an air pattern that actually disrupts the combustion process.